Okay, so yesterday we did calculating that R value by hand, big formula, all the sums in that table, and then we did it with the calculator. The next thing we need to talk about is determining if that R value is considered significant or not. And if an R value is considered significant, it tells you that the correlation is significant between the data, and then you can make a determination that whatever variables you're comparing are related in some way. Okay, so how we determine if an R value is significant. We're going to find a critical value in a table in your packet. This table that you're looking for is the very last one, table 11. Says critical values for the Pearson correlation coefficient. Remember, that was that other name for R. So you're going to have a level of significance. It will either be the 0.05 or the 0.01. We don't worry about having to solve for that on our own. Thank you. You too.
Hey, let us know what the beats, guys.
Okay, I will. Do you really want to know?
Okay,
I will do that.
Thank you.
Yeah, thanks. Okay, and then our N values are how many data points are in our sample. So if you had 4 data points in your, or 5 data points in your sample and a level of significance of 0.01, we would have this critical value of 0.959, for example. Okay, so if the absolute value of R is greater than that critical value you find in your table, then we say that the correlation is significant. If it's less than it, we say it is not significant. And what we want to happen is we want it to be significant. That tells us there's that relationship between the variables. Okay, so we're going to do this with the problem that we did yesterday together. If you flip forward 2 slides there, this is the data we used yesterday. We calculated the R value by hand, and then we checked it with the calculator, and this is that R value that we got. We got negative 0.908. Okay, so with that, we're now going to determine if that's significant or not. What's the N value here? How many data points do I have? I have 7 data points. Okay, so now let's find the critical value from our chart. They're telling us we have a level of significance of 0.05. So on that critical value Pearson coefficient, we're going to go over to 0.05. Down to 7, and you can see that value is 0.754. Good? Okay. Absolute value of R is equal to positive 0.908. That is greater than 0.754. So what does that mean? It is a significant correlation. Okay, so yes, we have a number close to 1 or negative 1, but even more than that, we have enough data points to say that that R value is giving us a good enough relationship between the variables that we're comparing. Okay? Questions? Okay. You can even summarize this when we say level of significance of 0.05. You could say, we're 95% confident, or there's a 95% chance that there's this relationship between the variables. You don't have to do that as much with this type of problem, though, as we do with those confidence intervals. Okay, so we're going to skip over the next problem because we didn't do that one yesterday. Okay, so hypothesis testing now for correlation coefficients. So yesterday I told you this guy here, it looks like a lowercase p. We pronounce it rho. That's a Greek letter. That is for the population. Okay, so a population correlation coefficient is rho, and our sample correlation coefficient is R. So that's what we're able to calculate on our own from our sample data. When we do a hypothesis test, we do it for rho. We always do it for the population. And when you do this, it will always be, number 1, a 2-tailed test, so we don't have to worry about left tail, right tail. And it's going to be rho equal to and rho not equal to. I should probably make those look less like a P. Let's see here if I can do that this morning. Something like that, sort of. One smooth curve. 0 and not equal to 0. when we say rho is equal to 0, we say that there is not a significant correlation. And when we say not equal to 0, we say there is a significant correlation. I know that seems backwards. Okay, so our hypotheses will always look the same for these type of tests. You don't have to worry about these changing in any way. And then our claim, most of the time, I'm going to say 90% of the time, is going to be that alternative, that there is a correlation. It's usually what we're trying to prove when we do a correlation coefficient. We use a t-test for this. To get our t value, the formula changes quite a bit from the one we did when we were testing for a population mean. So we're going to find r. If we don't have it already, we will probably use a calculator to find it, just because there's quite a bit of work involved with that. And then in the denominator, 1 minus r squared over n minus 2. Again, n is the number of data points that you have. And then you're going to compare that to your critical values. Now this is different. When we find critical values, we're going to use our t-chart. Before, when we used our t-chart, our degrees of freedom was n minus 1, because we only had one variable. Because we have two variables now, an x and a y, our degrees of freedom will always be n minus 2, which is also why you see that n minus 2 in the denominator there. It's part of our margin of error. Okay? Good? Great. Okay. So these are the steps for the hypothesis test, very similar to what we've done before. So we're going to state the null and the alternative, level of significance probably going to be given to us, degrees of freedom n minus 2 for two variables. We're going to find the critical values on our t-chart, which I'm pretty sure I've copied in the packet for you there. We're going to find the test statistic using R. We're going to determine if we reject or do not reject, and then we're going to interpret that decision. All right, so let's try a problem. So suppose you used 10 pairs of data to find a correlation coefficient of 0.874. Test the significance of this correlation coefficient. Use alpha equals 0.05. All right, so starting with the null and the alternative, here we don't have to worry about, certain set of numbers, if there's 30 values or normally distributed or anything like that. Okay, we're just using the data as we have it. All right, so again, the null and the alternative are always going to look the same. Rho equal to 0, rho not equal to 0. Okay, and let's make our claim the alternative. We're claiming that there is significance with this correlation coefficient. All right, so let's find our critical value of t on our chart. To get the critical value of t, you need n, and you need your degrees of freedom that follow. What's n? And what's the degrees of freedom? 8. 2 less for two variables. All right, so did I copy it in here? Yes, I did. Okay, so find your t distribution. Level of significance, 0.05. It is always a two-tailed test for these, okay? So you're going to go to the middle column, and then we're going to go down to 8 degrees of freedom. It is 2.306. Because it is a two-tailed test, we're always going to put plus or minus in front of it. Remember, if it's left tail, we put a negative. If it's right tail, we put a positive. Two-tail plus or minus. Okay, so you can draw those rejection regions. Negative 2.306, positive 2.306. Okay. Now we're going to calculate our t value using that formula. 1 minus r squared over n minus 2. Did I write that right? Make sure I don't mess that up. Yep, we're good. Okay. R we were given 0.874. Square root 1 minus 0.874 squared. And then n minus 2, our degrees of freedom is 8. And we type it in our calculator. Okay. So square root of 1 minus 0.874 squared over 8. Careful with the parentheses and the fraction on this one. Denominator is about 0.1718. And then if I divide, I get 5.087 is my t value. Okay, so is it in my rejection region? Yes. So do we reject or not reject? Reject. And remember, you are always rejecting the null hypothesis when we do our hypothesis testing, okay? If we reject the null, we say there is enough evidence to support the claim. I'm using that same statement we used before. And the claim is that the correlation is significant. Okay, so if you reject, it's a good thing. You're saying the correlation is coefficient. Is significant. If you don't reject, you're saying there isn't a significant correlation. Okay, so it's always going to look the same every time. Two-tailed test, same hypotheses. T-values will change based on your degrees of freedom and your level of significance, but there's not going to be a whole lot of variation with these hypothesis tests, which is nice. Yes? This one and the other one we just did. Not a whole lot. You're just using a different method. So here you're doing a whole hypothesis test versus there you're determining it significant just with the alpha value. This is typically more accurate than that. Yeah.
What are you doing to find the claim? Are you just always going with?
I just always say that my claim is my alternative because that's what you want when you're trying to, if you're calculating correlation, you're trying to show a correlation. Okay, so unless it says somebody thinks that there isn't a correlation, that would be the claim that there isn't one. But in most cases, we're claiming that there is. So if you have a choice on which one, you're going to put it on the alternative. Okay. All right. Anything else? Okay. So we won't do another one of those again because they're pretty much the same. So you can skip over this you try problem. The last thing that we're going to talk about is correlation versus causation. Correlation is what we're talking about now. When one variable affects the other variable in some way. If one increases, it causes the other to decrease. Or if one increases, it causes the other one to increase. Or maybe there's no correlation. One has no effect on the other. Causation is a little bit different. Okay, so causation is the sun. Ooh. Did you see I touched my board in that one? Those aren't even related. Oh gosh. Hold on. Let's see if I can get it back up. It is just a whiteboard. That's why I thought it was weird. There is zero technology here. It was just at that exact second that happened.
I was doing a presentation in Gillette's class, and I thought this thing was a smart board, but I kept tapping it. And
it didn't do anything.
And Gillette would hit it as soon as I hit it.
Oh no.
So like the entire presentation, and everyone started laughing. Why is everyone laughing? Then I got to my table, and I looked at it and I said, oh my God, it's a whiteboard. I felt so dumb. Got nailed.
There you go. Mr. Gillette just let it go. Yeah, that's good. Okay. Sometimes a correlation can look like there is one when there truly isn't. Like if you saw that last weekend, a lot of people got sunburned and ice cream sales went up. You might be able to compare those two and say that sunburns cause ice cream sales to go up, or ice cream sales going up cause sunburn. But those don't correlate to one another. They just happen at the same time because it happens to be sunny. What causes both of those to happen is that it's hot outside, right? So the sun, the warm weather, causes ice cream sales to go up. The sun, the warm weather causes sunburn, and bad choices cause sunburn, right? So there looks like there's a correlation between these two that really don't affect one another. There's this third party factor that's affecting both of those things at the same time. So that's something we have to think about when we're looking at data and looking for a correlation. We want to know, is there a direct cause and effect relationship between those two things? Or is there something else affecting both of them that looks like it's making them correlated to one another? So for example, it says the two variables below are shown to have a correlation, but no cause and effect relationship. Okay, so maybe as one goes up, the other goes up, or one goes down, the other goes up, something like that. But they don't affect one another directly. Give at least one possible explanation for the correlation. So what could be that third party factor? What could be that outside source that's causing both of these to change? So value of a home and the lifespan. So maybe we found that as the value of a home goes up, that person's lifespan also goes up, okay? Or as home prices in general go up, then lifespan also goes up. So those aren't affecting one another directly, but what could affect both of those? The economy could affect both of those, right? Okay, so people have more money. If you have more money, you have more money to spend on houses. If you have more money, you can afford better health care, right? And then the lifespan would increase from there. Make sense? Or just time in general, a timeline, right? So as the years increase, we get more medical advances, houses become more expensive, all the fancy things we can buy. What's up? Okay, great. All right, you guys, last problem of the day is figure out that outside source for both of these. Why there is shown to be a correlation between these two things, and possibly explain why that relationship is happening. We're going to give you a few minutes to brainstorm. Go ahead.
Oh, I already got it. Don't get mad at me.
Don't get mad. Okay, great. Can't wait to hear it. Okay, are we ready to discuss? Okay, so give an explanation for why ice cream sales and homicide rates are related to one another, given that there is no cause and effect relationship. Yes?
More gangs, so that means they're buying ice cream.
Why do the gangs buy ice cream?
I mean, we'll buy ice cream.
Everybody buys ice cream, right? So increased gang activity in the region. Okay, yes.
Kidnappings.
Kidnappings.
People in ice cream trucks. And.
Oh, yes. I've never let my children buy ice cream from the ice cream.
Really?
Not kidding. They don't even look like trucks anymore. They just look like white vans driving around the neighborhood. Not fan.
But that's a pretty good correlation.
I just tell them, we have ice cream in the house. You don't need to go outside and buy it. Okay, great. Alcohol use and tobacco use. Correlation. Depression. Okay. Addictive personalities. Right? There could be issues with that. Anything else? Okay. I love this. Is my favorite one. Marriage rate in Kentucky and the number of deaths caused by falling out of a fishing boat. Yes. Bipolar disorder. Yes. Can cause both of those. Yes.
Life insurance claims.
Life insurance claims cause more marriages, cause more.
Just the fact that it's summer, maybe, like more people get married in the summer, but people also go fishing.
There's more people on a boat, so more people can fall out of the boat. Yes.
Emotional stress caused by a spouse.
Yes. It's possible. The book's answer to this one was coincidence. So that's actually a legitimate answer, right? I mean, it could be complete coincidence that there is nothing that causes both of those to happen, but when you compare the two, it looks like there's a correlation. So all of your answers are right, and that is right. There's not one right answer. So great. Okay. Questions? 9-1, that's it. All right. So 9-1 Math Excel is due on just double checking. I think it's Tuesday next week. I'm gonna double check. Yeah. Okay, so Tuesday next week. You guys have about 20 minutes now, so you can work on your project that is due Monday when you walk into class, or Math Excel due Tuesday. Yes, ma'am?
Can I go back to the first topic, please?
Yes, I can. Let me unfreeze that. The first problem we did was this one. Okay, there you go. Any questions on the project before I put on Donald Duck? Yes.
Just number 8, like, how exactly do you want us to set it up in the calculator?
So you're going to be using a t-test for that in the
Okay.
calculator, and we did that in 7.3 if you want to see
Yeah,
look
I
at different
remember
selections. So
that.
if you look back in the notes, that can kind of help you with what you type
So,
where.
like,
So calculate, or test and t-test. And then
And then
from
you just
there, you'll have to
copy
know
that
what.
onto here?
Yeah, that's the screen you're gonna,
Or, like,
yeah,
do you want us to put this, or, like, what comes up? when we
that
calculate?
and what comes up afterwards.
Oh,
But
okay.
you're gonna need the p-value then to answer that question.
Okay.
Yep. Okay?
Yep.
Anything else?
Might P on like the number 8 came out as 0.
It could come out as 0 or very close to 0.
Oh, really?
A lot of
So that's-
people got like very small negative exponents, like times 10 to the negative 13th
So
or
I
something.
can put 0.
You can put approximately 0. Yeah,
Okay.
your calculator's probably just rounding it.
Yeah.
Mm-hmm.
And then can I sit with you?
Yes. Yeah, you can pull up a chair over there if you want. Let me get this. Taylor, are you good on this? Taylor, do what you need on there. Yeah. Owen. I have the first part graded. I can give those to you now.
Oh my god.
I have not.